Explorer-1, NASA's farthest-traveling spacecraft, continues its journey through the vast and uncharted regions of the universe, almost 50 years after its launch. Researchers are amazed by the mysterious data this historic probe continues to send back to Earth. Despite signs of aging and potential malfunctions, the spacecraft's scientific contributions remain invaluable. Explorer-1 was part of NASA's early space exploration efforts, launched in 1977 alongside its twin Explorer-2. Both spacecraft, weighing 720 pounds each, about the size of a small car, were designed for long-term missions to study the outer planets, relying on gravity slingshots to move from one planet to another. However, Explorer-1 was the first to venture further, eventually surpassing its twin on December 15, 1977. It played a pivotal role in studying Jupiter, capturing over 3,700 images and providing groundbreaking data about the planet's moons and rings. Later, it discovered new moons and made key findings on Saturn's moons. In 1990, Explorer-1 was tasked with NASA's interstellar mission, which aimed to collect data beyond the solar system. By 1990, when it was about 6 billion kilometers from the Sun, the spacecraft began transmitting stunning pictures of distant planets and the Sun's environment. However, as it journeyed farther into space, its cameras were shut down to conserve energy, and its mission shifted to collecting data about the interstellar medium. Explorer-1 continued its journey past the edge of the solar system, officially entering interstellar space in 2012, a milestone not publicly confirmed until 2013. As of 2018, Explorer-1 and its twin Explorer-2 are both officially beyond the solar system, sending back crucial data that no other space mission has been able to provide. Despite being in space for over 45 years, Explorer-1 is still operational, though experts have noticed some strange anomalies in its performance. While it continues to send data and receive commands from Earth, the information it transmits is becoming increasingly cryptic. The spacecraft's communication systems appear to be functioning well, but the data it returns doesn't always match what is expected. Scientists are puzzled by these discrepancies, and although the spacecraft's antenna is still intact, the signals it sends are causing concern. Interestingly, each spacecraft traveling into interstellar space, including Explorer-1 and 2, carries a 12-inch gold-plated disc with messages, sounds, and images from Earth. This disc, meant as a backup in case the spacecraft is discovered by extraterrestrial life, includes greetings from U.S. President Jimmy Carter, former UN Secretary-General Kurt Waldheim, and various cultural artifacts. However, the idea that the spacecraft is under the control of extraterrestrials has been quickly dismissed by scientists. Despite these mysterious signs, engineers assure that Explorer-1 is functioning as expected for its age. At 45 years old, its systems are showing signs of wear, but it's still operational. The data being returned by Explorer-1 continues to pose a mystery, contributing to the ongoing fascination with this remarkable spacecraft. The challenges faced in diagnosing and addressing the issues with Explorer-1 are immense, as engineers work diligently to navigate these complexities. Despite its remarkable legacy, the spacecraft's current difficulties stem from a combination of its age and the harsh environment of space. The team is leveraging their experience and the spacecraft's inherent resilience to address these problems. Their careful and patient approach is critical in handling the large delays in communication and the complications of working with a spacecraft that is both extremely distant and significantly older than initially expected. The issues faced by Explorer-1 are likely caused by high-energy cosmic rays interacting with its delicate electrical systems. These particles, originating from distant cosmic events such as supernovae, travel through space at nearly the speed of light. When they strike the spacecraft, they can penetrate its outer shell and affect its internal electronics. As the spacecraft spends more time in space, the probability of these cosmic rays impacting its systems increases, potentially leading to irregularities like those detected in Explorer-1's telemetry data. Engineers have long been aware of the risks posed by cosmic rays to spacecraft and astronauts. Although they have developed various protective strategies, such as designing sensitive electronics with shielding, creating redundant systems, and using error-correcting codes in data transmission, The unpredictable nature of cosmic radiation remains a significant challenge, especially for spacecraft in deep space over long durations like Explorer 1. Despite these obstacles, engineers continue to monitor the situation, carefully analyzing the data from Explorer 1 to pinpoint the cause of these irregularities and devise strategies to mitigate their effects on the spacecraft's operation. Given the spacecraft's age and prolonged exposure to cosmic rays, the issues are not entirely unexpected. However, the team remains committed to resolving them, keeping Explorer 1's mission alive and continuing its contributions to space exploration. Explorer 1 has far exceeded expectations for its original mission, which was intended to last only 5 years. Launched on September 5, 1977, just 2 weeks after its twin spacecraft Voyager 2, Explorer 1 embarked on a journey that took it far beyond the boundaries of our solar system into the vast reaches of interstellar space. The Voyager missions were a testament to human ingenuity, designed to take advantage of a unique alignment of the outer planets that enabled a grand tour of Jupiter, Saturn, Uranus, and Neptune. Explorer 1 made groundbreaking discoveries during its flybys of Jupiter and Saturn in the late 1970s and early 1980s. In 1979, it captured stunning images and data from Jupiter's largest moons, Io, Europa, Ganymede, and Callisto, uncovering diverse landscapes such as active volcanoes on Io, icy surfaces on Europa, and hints of a subsurface ocean that sparked scientific curiosity about the potential for life beyond Earth. Later, during its flyby of Saturn in 1980, Explorer 1 provided detailed images of Saturn's rings, revealing intricate patterns and the interactions between ring particles, while also discovering new moons orbiting the planet. After completing its primary mission goals at Saturn, Explorer 1 continued its journey into interstellar space, crossing the heliopause in 1990, the boundary that marks the transition from the solar wind to the interstellar medium. It was in 2012 that Explorer 1 became the first human-made object to enter interstellar space, surpassing all expectations for its lifespan. Originally designed for a 5-year mission, it continued to function for over 4 decades, transmitting valuable scientific data back to Earth, including measurements of cosmic rays, magnetic fields, and plasma waves. Even though its power sources have weakened over time, Explorer 1's nuclear power generators have continued to supply the necessary electrical power for its instruments and communication systems, enabling ongoing scientific exploration of the outer reaches of the solar system and beyond. However, recent anomalies in the spacecraft's telemetry data have raised concerns among mission scientists. These anomalies are thought to be caused by the effects of cosmic radiation on the spacecraft's electronics. High-energy particles from sources such as supernovae and solar flares have disrupted sensitive equipment, and prolonged exposure to these particles has led to glitches in the spacecraft systems. NASA engineers have implemented various techniques to minimize the impact of cosmic radiation on Explorer 1 and other deep space missions. These include shielding sensitive electronics, employing redundant systems, and developing error-correcting codes for data transmission. Despite these efforts, the unpredictable nature of cosmic radiation remains a challenge, especially for spacecraft operating in deep space for extended periods. The recent anomalies in Explorer 1's telemetry data require careful attention from mission engineers. Extensive diagnostics and simulations are being conducted to identify the root causes of these irregularities and to develop potential solutions. The spacecraft's vast distance from Earth, around 14.5 billion miles, adds to the complexity of troubleshooting and resolving issues in real time. Nevertheless, the engineering team remains committed to preserving the spacecraft's legacy of scientific discovery and ensuring that Explorer 1 continues to contribute to our understanding of the universe, far beyond the boundaries of its original mission. The team working on Explorer 1's mission faces significant challenges due to the spacecraft's extreme distance from Earth, approximately 14.5 billion miles. This vast distance presents numerous difficulties, particularly when it comes to troubleshooting and communication. Explorer 1 is currently in interstellar space, far beyond the reach of any rescue or repair missions. The advanced technology required for such an operation is beyond what we can practically achieve. Messages sent from Earth to Explorer 1, traveling at the speed of light, take about 21 hours to reach the spacecraft. Similarly, any responses or data sent back to Earth take another 21 hours, making two-way communication a process that spans 2 full days. This delay makes it extremely difficult to solve problems in real time, as engineers cannot quickly send new commands or adjustments. Each instruction must be carefully planned to address potential issues, as it may take up to 2 days to confirm the outcome of any changes. Unlike missions closer to Earth, where engineers can rapidly communicate and adjust strategies, the prolonged communication lag requires a much more thoughtful and calculated approach. Each command sent must be highly precise to avoid further complications, given the time required to confirm its success. This means the engineering team must meticulously review and test each order before sending it to the spacecraft, ensuring it has the intended effect. Moreover, Explorer 1 is now more than 40 years old, having been launched in 1977. The systems it operates on were designed with the technology available in the 1970s, presenting additional difficulties in terms of maintaining and troubleshooting the spacecraft. The harsh conditions of space, including exposure to cosmic radiation, extreme temperatures, and micrometeoroid impacts over the course of 4 decades, have contributed to the wear and tear on its systems, making repairs even more challenging. Despite these obstacles, the engineering team is committed to resolving the issues. They are considering various potential causes for the spacecraft's problems and using simulations on Earth to test possible solutions. This careful, methodical approach is essential, as any incorrect command could worsen the situation or lead to a loss of communication with the spacecraft. Fortunately, Explorer 1 was designed with redundancy in mind, including backup systems that can be activated if necessary to restore normal operations.